So thanks again for that kind intro. I have to say it's really nice being able to finally present PoliMOR here in person. The last couple of years I've had to do this all virtually, including last year. So PoliMOR, which used to be named Quicksilver, is just a shorthand for a policy engine made to order. And we chose that name because it sounds like a polymer, which is like a structure that consists of nearly identical subunits that can be combined into different shapes to achieve different ends. As a refresher from the previous LUG talks, PoliMOR is a distributed, extensible, and automated policy engine. It's designed to allow for tasks on Lustre like migration between tiers, purging, telemetry, and data collection. By distributed, we mean that it is a bunch of agents connected via a distributed messaging queue system, in our case NATS, and that it is both fault tolerant and scalable. By extensible, we mean that it is agent oriented, so we have a bunch of single purpose tasked agents that are all supposed to do one thing, and then they all coordinate with each other with the messaging system. And it is extensible in that you can add different agents to achieve different ends, and it will scale because none of the agents have to know about any of the others. They just respond to events. And by automated, we mean that you define a set of invariants in policy files that it has to maintain on the system, and that there should be little or no intervention by end users or admins. Just a quick diagram to go over what we've talked about in the past. So in the gray box, you have your traditional Lustre file system that can contain multiple tiers and billions of files. And then in the blue box above, we have PoliMOR. And then in our first inner box, we have our scan agents. And then those scan agents walk the file system, and eventually we'll be able to collect change logs and also database records. And then they process and collect that metadata and send it along a messaging bus system through our PoliMOR API that then goes to a set of policy agents who have been fed policy specification files, who then act on that information to make policy decisions that are then passed along to a set of agents that we call our file system agents that then act on that information. And then, as said, those agents can be purge agents, migration agents, archival agents for things like HPSS or database recording agents. And then it is their job to then communicate back with the file system and to handle those actions. So at previous LUGs, we've discussed the need for PoliMOR, that as file systems have gotten more and more complex, both in size and the number of tiering, that admins need an easy and reliable way to implement policies for different users, groups, and projects. We've discussed the design of PoliMOR in much more detail. And we've also given preliminary results from some of our early single node and cluster testbed results. And then today what I want to discuss is our actual early results coming from our deployment onto the Orion file system in live production. So just as a reminder, Orion is the ORNL file system for its latest supercomputer. It consists of 40 MDS servers, providing almost 10 petabytes of metadata storage and DOM, and then 450 OSS servers that have 10 petabytes of NVMe flash tier, and an additional 679 petabytes of hard drive capacity tier storage, running a custom Cray version 2.5 of Lustre, and all interconnected via Slingshot. And then for us, we are doing our tests on a set of 9 Orion util nodes that use 24-core AMD processors. with 128 gigabytes of RAM and connected to the rest of Orion via Slingshot. So we started out wanting to do some basic agent scaling tests to figure out the appropriate tunings and knobs to get the best results for Orion. And we started out by creating a synthetic project sandbox that consists of 11.7 million files spread across a directory tree of almost 28,000 individual directories into a directory tree. We set all the files to being purgeable. And then the files were all randomly sized uniformly between 1 byte to 2 megs, following the standard PFL layout of Orion, which means that the first 256 kilobytes go onto the MDT. And then the following segment up to 1 megabyte will go onto the NVMe flash tier, and then everything beyond that just goes out to the hard drive OSTs. So now that that's out of the way, we can get to the good stuff, the graphs. So the first scaling test we did was on our scan agents. So we did a 1 million run for each of these tests. And on this graph here, as you can see, on the y-axis, we have what the file scan rate was in aggregate per second. And then our x-axis is the number of agents, where each bar is a group as to the number of sub-workers within each agent. And then a worker in this context is a sub-process that is what is actually responsible for actually doing the walking of a directory itself and doing the scan of the files and then reporting that back up to the agent, which then in turn reports that to the rest of the system. And then basically what we found is that as we go up from 1 to 5 agents, we have almost perfect linear scaling. And that we topped out at about 22,500 files per second. And then we also found that for the most part, as you increase the number of workers per agent up to 6, we tend to also see an increase per agent. But then after 6, on some of the runs, we got inconsistent results, and we started to notice that like with 8, sometimes it would do less well. So we might be starting to hit the limit of the system for each node. And then, like I said, we were able to get 22,500 files per second, which is a large improvement over last year, where we were basically measuring the results in hundreds of files per second. And we made some changes. Among those is we dumped LFS find, and we basically implement, and basically the workers use lazy statx instead. So instead of actually going out to the OSTs and getting the very latest file data, we actually just query what the MDSs have. And then we also don't use read directory. We use a lower call in Linux called getDense that lets us batch them up so we can get back like whole directory entries at a time instead of having to go back and forth. And then we also implemented work sharing between the agents. And we also implemented caching of the directory handles so that like now as you go down and your worker is reading through a directory, when it finds a file, it reports that file back up. But for any directories it finds within the directory it's been tasked with, it actually opens those file handles and will return those file handles back up to the agent. So that way, if the agent decides that it needs to descend and issue that work to a worker, instead of having to pass the path through, it can just pass the file handle down through a Unix domain socket, and then that way the worker is just basically using all the at calls instead of having to do full path resolution. And basically, all these changes that we made, it gave us a 10 order X improvement. So. And we still think there's some more that we can do to squeeze out some more. Moving on to the policy agent, you can see once again we have the same type of bar graph. You have your x-axis being the number of agents grouped with the number of workers, and your file rate that is being processed. So that's decisions being made by the policy on each file. And you can see that we also have near perfect linear scaling again, although we have seen in our runs that the ideal number of workers, which in this case is just separate coroutines running in the same space, seems to be the optimal number. And the reason for that is because of gnats. We've kind of noticed that most of the time in the policy engine is actually not taken by the policy decisions, but is being held like 80 to 90% of that time is being spent just dealing with the gnats messaging queue system. So we have some work to do there because you can see we get about 10,000 max, which is about half of our scan rate for the same number of agents. Finally, we did purge agent scaling. And basically what we saw here, to much of our chagrin, is that we actually get better than linear scaling as we increase the number of agents. And that also performance does not scale linearly with the number of workers either. And I'll get into why this is. And I should also add that our purge agent is not only just doing unlinks, but is also doing full synchronous stats in order to make sure that timestamps have not changed from the time that the scan agents have seen it and that policy decisions have been made. And also because we have noticed that there can be occasionally there can be inconsistency in the timestamps between what the MDS reports and what the OSTs report, and that can be up to like multiples of days. We saw this about maybe on Orion, I think once in a million. So like 1 in every million files can do that. And having talked to Andreas, he thinks it's just due to like improper closes. So the MDSs are just never being updated. So we just have a nice little safety check there. So this is both the stat and the unlinked time. So getting into why we saw that behavior. So what we've seen, and this graph here, on the x-axis you have time in seconds, and the y-axis is the purge rate. And I'll also add that the x-axis is not consistent between each of the graphs, because basically if you try to do that, by the time you're doing 5 agents, it's like this in comparison to like 1 agent, so you can't see any detail. But the y-axis is consistent. And basically what we've seen is that like with less than 3 agents, regardless of the number of workers, and regardless of what agents we use, you basically see this seesaw behavior in each of the agents, where basically this graph in each of these colors is the actual instantaneous rate for each of the agents. So you have this seesaw behavior that kind of ends in a tail off. And then we've noticed that, well, when you go above 4 agents, this behavior is disappearing on Orion, right? You either get like this nice slow ramp up, or like in the case of 5 agents, it's just flat and high the entire time, which, is why if you go back, you can basically say, yeah, which is why we get that better than linear scaling right now, because something weird is happening and we haven't figured out what it is. Because basically the 1 and 2 and 3 agents should be doing a lot better than they are. So this is something new that we've seen when we've moved on to Orion from the testbed systems. So I've been using the time here at LUG, to actually pick some of y'all's brains. You know who you are. You've all seen these graphs. So then after doing the per agent scaling, we then wanted to see, okay, what is the time it takes to actually do a full Orion file system scan with directory traversal? And this is running with 5 scan agents with 8 workers and 10 policy agents with 2 workers. Again, we're running we're running twice the number of agents because we saw that we get about half the level of performance of files processed per second with the policy agents right now until we figure out what's going on with gnats. And we were able to scan like 3.6 billion files in just 92 hours. And we have, a mostly nice, cumulative increase. Especially early on, we get that perfect 22,500. And then we have like 3 little flat spots here. The first and third flat spot is basically when the NAT servers locked up and decided to stop giving messages to the agents and basically required us to go and kick them. And then that second flat spot is just when we had a small glitch between the MDS and some of the util nodes. So they couldn't do anything on Lustre. And we had a couple little slowdowns if you look close. And that's just where like an agent would like fall over. And again, that's mostly just due to NATs. We recently upgraded the client version and we're just getting a weird error coming out of it every now and again. So sometimes a agent has to be restarted right now until we figure out what's going on. But, but the silver lining here is that at no point in this run did we ever have to start over, right? We never had to completely bring the system down, bring it back up. We had to restart, the NAT servers. But once we did, NAT servers started issuing those messages again, never lost any messages. And basically, and even when an agent fell over, You restarted it, it picked up right back where it was before. So even with all that, we still made a nice consistent run through, and we were able to get it done in 92 hours. So we kind of consider this a win because, with distributed systems, it's not just, oh, look how good I can do. It's, hey, look what I can do in the face of a lot of failures, right? I'm able to pick myself back up and keep going. So this graph here is the 1 minute load average during our run of doing the full file system walk. X-axis is in hours. Y-axis is the 1 minute load average. And what we found was that there was basically no difference in system load on the MDSs when we were running the full file system scans and when we weren't, compared to like a 24-hour observation window. We had an average of like 5.2 and a median of 0.27 when we were running. And then we had the same mean when we weren't, with a slightly lower median. And again, you would expect the median to be lower because, again, based upon this graph, you can see there's a couple MDSs that are just really busy, so they're pulling up the average. So our impact on the system appears to be minimal at this point. So we consider that a win. So next for us and the rest of the PoliMOR team is moving into full production onto Orion. So doing purge and migrate. And then also, as you can see in this talk, adding some supervisor tasks to help handle the agents and NAT servers when errors occur. So that way I don't have to go and re-kick them. That way, we have a nice little supervisor process that'll just bump them for me. And we want to improve our NATS usage improvement because there's no reason why the policy agent should be so slow in comparison to the scan agent. And then for the scan agents, we want to improve the work sharing algorithm some more. Have some demand-based time, so that way we don't have like that early ramp-up period before sharing starts. And we also want to reduce the amount of scan work by using change logs and using our sharded database that we maintain to provide hints, so that way maybe eventually we only have to do a full file system walk occasionally to help rectify records. And then we also have several potential optimizations in the purge and migration agents planned. We want to add directory caching and directory aware functions like we did with the scan agent. And we also want to cluster the work by directories per agent, basically sharding them out, because one thing we've seen with the purge agent and the migration agent, especially the migration agent, is that, as you're taking that directory lock, and when you're taking that directory lock, another migration agent cannot make much forward progress while that lock is being held. So we want to take care of that by just saying, this one goes to this agent, everything in this directory goes to this agent, and then we hopefully won't have that problem in the future. Additionally, more forward-looking, we want to handle more complex policies. And we also want to add some non-luster agents to handle other file systems, to handle archival features with HPSS, and to handle some of the edge and stream initiatives at the ORNL lab. And we are always looking for collaborators. So if any of you are interested, please hit me up. I am happy to talk about it. I'm happy to take any suggestions. I'm happy to give early code releases to see what you all think. And finally, I want to conclude my talk by thanking my fellow developers, Angus George, Keaton Maheshwari, Rick Moore, and the ever illustrious James Simmons. So that concludes my talk. Any questions?
So, Chris, I wanted to, as Kevin Harms, Argonne, I wanted to better understand the purge and policy. So, are those taking the results of the scan agent and then working through those? Or, for example, is the policy agent scanning, trying to find matches to the policy, or it already has a list that it should execute the policy against?
So what's happening is that the scan agents are walking the file system, and then anything that meets a cursory approval process gets passed along through the messaging queue system to the policy decisions, who are fed these policy specifications dynamically. They make the decision as to what happens, and then they send those commands out along other messaging queues that then go to those individual purge agents who then receive it and act upon it.
Okay, so the purge agent is only purging files. So
Yeah.
when you
So
give,
everything here it's kind of a agent-oriented microservice, I hate that term, thing, where basically you have these agents and everything is very single focused. So that way, just do one thing and do one thing well.
Hi, Aurélien Delémont, NVIDIA. Maybe I missed that, but I'm not sure I understood correctly. Are each agent on a different client? I'm trying to understand how many clients you have, actually. It wasn't clear to me.
So we had 9 for this. We had 9 Orion util nodes. The agents, we did do some overlap. There is no reason why the agents cannot be shared or even run all on one node, other than you just don't want to hit, Lustre that hard. Like you probably don't want to run your scan agents on the same ones that you're running your action agents on, because you don't want to be doing the scans on the same ones that you're doing your unlinks and your purges.
Okay, so
you don't have to.
You can distribute them as you wish across clients.
Yeah.
And for your test?
So for this test, everything was distributed up to 9 nodes.
Up to 9 nodes.
Yeah.
And one
So,
addition.
so we had the 9 nodes.
Okay, this is what I missed.
With 24 core AMD EPYC processors, and they were connected to the Orion proper system via Slingshot.
Okay, and is it correct that you don't keep a persistent memory image of all the scan? Every time you want to apply a new policy, you need to scan again?
So we have divorced policy from scan, right? So you can specify a policy and then you can scan whenever you want. Now, one of the things we have, it wasn't in the diagram, but we do have a recorder agent. Let me go back to that. We as one of our file system actions, we have a recorder agent type that writes to a sharded SQLite database that will dump all the results into it, because some users want to be able to go and search that database for like whatever. So the file system data actually does get stored, but as of right now, we are not ingesting that data back into the system. Eventually, that's one of the enhancements we want to look at maybe doing, is that if we're already doing this work, we can use that to kind of lessen how often we need to do full file system scans. So that way you only have to do full file system scans for like occasional rectification.
Oh, okay. So
that makes sense?
Yeah. So you are keeping only the entries which match the policies, or all the file system entries?
Oh, okay. So think of the policies as being like a filter, right?
Yeah.
So the scan agents have like a very high level filter, right? And then they pass everything through the messaging queue. Can you hear me? Okay. They pass everything through the messaging queue, right? Where they're picked up by the policy agents. Then the policy agents look at their policy and they make a decision, right? And then it might be that nothing has to be done with them, so nothing more happens. It might be that a file needs purging, so it goes on, and then the purge agents pick up on it and then handle it. Might be that it needs migration, might be that it needs archiving.
Okay. So my thinking was, if I have a new policy, or if I change my policy and I want to apply this policy, I need to launch a new scan.
If you want it to take effect immediately, yes. At least for right now, yes.
Okay.
Eventually, what we'll be doing is we'll actually be tagging. Right now, like when you want to do a scan, we have a command line tool that says go and do scan, right? So that way people can put it in like a cron job or whatever, and they can specify a directory that they want scanned or the whole system. And right now that just goes straight to the scan agents. Eventually, what we'll probably end up doing is we'll probably tie that into the policy agents and make that an optional part of the policy. So that way the policy will be able to actually directly send that to the scan agents when they need to do something.
Okay.
And that'll also work out well once we add, those other types of scan agents that look at change logs and the database.
Okay, thank you.
Yes. But very good question.
Hey, one other question over here. Ellis Wilson, Microsoft. This is going to make people squeamish, but have you ever considered co-locating your scan agents and potentially your policy agents on the MDTs, MDSs,
yes,
and OSSs?
Yes, I have. You can see Jesse's laughing right here, right now. So this is actually something I actually did while I was here. Like I said, I'm happy to actually do this in person instead of virtually, because I've been picking people's brain about, well, if we have to run on separate nodes from the MDSs, how hard is it exactly, to just do the RPCs ourselves, right? Just bypass the whole VFS layer and the client layer, because we don't need all that locking and stuff. We're just doing stats. And I've pitched the idea of Jesse, since it's ZFS underneath the hood, we could just use ZFS send. I could have like a little scan agent just sits there and listens to ZFS scan right there on the MDT, and just sits there and just listens, and reports back. He says no.
Yeah, that was a bridge farther than what I was more suggesting, just having a Lustre client co-located on the same nodes, and then basically...
Yeah, I also asked about a thin client. That was my first thing before talking about actually crawling the MDTs. He said no too. Something about him being responsible for like 3 a.m. calls. I don't know.
Yeah. No, that's fine. I said it would make people squeamish, but thank you. Appreciate it.
But if there's interest in the community, I would be happy to develop it, because that is something I would like to do. Because, we should be able to scan a lot faster if we can actually just crawl it right there, either at the ZFS layer or like a thin client.
Thanks.
Sure.
Hey, Chris.
Yes, John.
Who can write and implement policies?
So right now it's restricted to the admins.
And then
now the admins can, of course, turn around and open that up to end users if they want.
Is that what you all want to do, is open it up to end users?
Jesse, is that what we want to do? He says no.
Now, based on what we heard from HPE on their, policies and trigger events, do you have similar trigger events that for purging, is it based on the life of if it exceeds a certain life, you purge automatically? Or do you set warnings like these files are candidates to be purged, and you let the users know, here's a report of if you want to keep them? And then the same thing with migration from performance capacity pool that you use. Do you then initiate, or do you always have to warn the users these files are candidates to be moved or purged before you actually do the work?
So speaking on behalf of ops at ORNL, they have been warned, because we clearly tell them they have 90 days, and that's their warning. Now for other sites, it wouldn't be any harder to add another agent type and a policy for that says, hey, if the file is greater than 80 days, right, send it to a warning agent whose job it is to send out the emails. Right. Again, this is the whole thing, early in the slides with it being extensible, right? We've made our agents and our API extremely easy to use so that people can go and just write their own agents to do whatever they want. Right. Because right now, even the policy agents are pretty simple, right? They look at the file, they figure out what file set in the policy it matches, right? You get a list of file sets that it belongs to. And then from that, you look at the actions that, apply to those file sets. And then you pick one based off of priority. Right. And the only thing that really does is that just ties it to the queue. Right. That just basically tells the policy agent like which queue to send it out on underneath the hood. So, we've made it kind of lightweight and flexible as much as possible.
Chris, Patrick Farrell from Oracle. I was taking us back one. About the client on the server. So that's actually something Lustre has explicit support for. There's a special way to mount them so they don't participate in recovery, et cetera. DDN does something similar for some of their data movers, puts them on the OSSs. So I guess what I'm saying is, while there might be operational issues, if you can get through that, go over that hump, I think that's actually a pretty good idea.
Yeah. You're speaking to the choir here. I absolutely agree. I think that the scan agents should be on the MDS, but unfortunately, I don't have root on those, or they would already be there. See, as much as James goes around installing Lustre on everything he can, toasters, refrigerators, I would be going around and installing the scan agents on the MDSs. All right. Thank you, Chris. Thank you for your time.